Hello, and welcome to a little video about Target 5B, where we're going to be determining better measures of center and spread for a data set. First, let's start by looking at some histograms. This should be a little warm-up because we did do a little bit of this on Mathia the other day. Okay, first of all, this is a histogram that shows ACT composite scores for randomly selected students at some school. How many students scored between 10 and 15 on the ACT? So what we do for this is we locate the interval 10 to 15, and we look how high it goes. And it goes up to four students. How many students took the ACT? I'm going to look at every single interval and write down the number of how high it goes. This goes up to 7, 9, 6, and 5. To find letter B, we add them all together. 31 students took the ACT. Letter C, how many students scored a 25 or more? Let's take a look at 25. Or more means to the right. That means we're looking at the interval 25 to 30 and 30 to 35. Add those two, that's 11 students. Okay, number 2. This histogram shows ages of swimmers on some team. Okay. Letter A asks us how many students are between 10 and 12. Let's locate that interval. From 10 to 12, we've got 8 swimmers. Letter B, how many swimmers are on the team? Once again, let's take a look at every interval and write down the amount of swimmers. So 7 here, 6 there, 8 in the middle, 7, 5, and then we add them all together and we get 33. Letter C. How many swimmers are 10 years or younger? Let's take a look. We start from 10, and younger means going to the left. That's younger than 10. So we got the intervals 6 through 8 and 8 through 10. That's 7 plus 6, 13 swimmers are 10 or younger. Number 3. This data below is the number of goals scored by professional indoor soccer team in their last 23 games. Let's construct a dot plot. Now, I think I accidentally printed this wrong for you, so my bad. We're going to redraw that line. Okay, let's do it. It looks like my smallest number is 8, and my largest is, let's take a look, 16. Beautiful. All right. So, 16, 8. I'm trying to space this out nice, see if this works. I don't know. Oh man, fingers crossed, right? 11, 13. Oh man, that didn't work too well, but you know what? That's okay. I'm going to do some computer magic. And doo-dee-doo-dee-doo. Move that over. Oh, technology. What a beautiful thing. Whoops. I'll just put 17 there for good measure. Okay, let's do this. So I went through this whole list, and this is what I ended up with. I ended up with 3 dots on 8. Oh, by the way, if you're trying to follow along with this video and take your own notes, I would pause, create your dot plot right now, and then compare it to mine. Okay, I ended up with 4 on 9, 3 on 10, 1, 2, 3, 4, 5 on 11, 1 on 12, 1 on 13, none on 14, 3 on 15, and 3 on 16. Number 4, Michael rolled 2 dice 21 times. He then found the sums. That means he added the 2 numbers each time he rolled. Here are the sums. Let's construct a dot plot. All right. Let's take a look at the numbers. The smallest number I have is a 2, and the largest is 11. Let's fill in this number line. 6, 7, 8, 9, 10. Okay, beautiful. If you are following along with this video, pause it, create your dot plot, and then compare it to mine. This is what I got. I got 1 dot on 2. 2 on 4, 3 on 5, 4 on 6. That is not a very straight line. Let's try that again. 1, 2, 3, 4. There we go. I got 5 on 7. I got 3 on 8, 2 on 9, none on 10, and 1 on 11. All right. Next, we're talking about data distribution. The overall shape of a graph is called a data distribution. And when we're looking at graphs, what I'm talking about is like a histogram or a dot plot. Okay. Remember that all 3 common distributions are data. They're skewed left, that means it's leaning left. Skewed right, that means leaning right. And symmetric, which is a perfect little mountain shape, I guess. So let's define all that. Skewed right. This means that the mean, so the average of a data set, is greater than the median, the middle of the data set. So it's skewed to the right. Symmetric means that the mean and the median are equal values. Skewed left means that the mean of the data is less than the median of the data, and it's leaning a little bit to the left. So let's describe this data. So in number 1, if we are to draw that shape of our data, it looks like it's leaning a little to the left. So I'll say skewed left. Okay. Next, we have this set of data. Let's draw its distribution. It looks like it's skewed to the right. All right, let's take a look at this next set of data. Number 2, let's draw it. It looks like it's skewed left. And lastly, oh, that one is perfectly symmetrical. Right. Lastly, what we need to do is mean the practice is good. Well, you'll have missed it. We are going to do that in class altogether, but the mean is the average, and in order to calculate it, we add up all the terms and divide it by the number of terms. Here's the official kind of symbols for it. Mean is represented with this symbol, with an X with a little line on top of it. It equals, this symbol means the sum, X with a little I means all of the data, divided by N, which is the number of data points. Let's write that in English. Sum of data, number of points. All right. That's about it for this video. Because the practice does happen in class, we do some measuring of averages among our classmates. Anyways, have a wonderful rest of your day. If you have any questions, make sure to ask me or your teachers. All right. Bye.